this email address at any time while we're working, and I'll grab it and I'd be happy to do that. But we can start with just adding and subtracting scientific notation in the meantime. How about multiplying and dividing? Is that something that you've talked about?
Yeah, I have some struggle doing adding, dividing, adding and subtracting,
Okay.
or all of them,
Good.
and I just find adding and subtracting harder.
Okay. So for example, let's just start with an example here. 4.7 times 10 to the third plus 3.2 times 10 to the second. Okay, so this is an example of a problem you might see, although it might be written like this, sort of out horizontally. Does that looks like something you've seen in class?
Yeah.
Okay. The way that always works, is to take problems that are in scientific notation and convert them to standard form. This is when you're adding and subtracting. Perform the add or subtract step, and then go back to scientific notation. Did you see that in class? Does that look familiar?
No, we didn't really discuss anything about it.
Okay, this is not the fastest way, but it is a way that always works. So for example, in this problem I'm showing you here, what is 4.7 times 10 to the third in standard form?
4,700.
Right. So 4.7 times 10 to the third is 4,700. And how about 3.2 times 10 squared?
320.
120. Okay. So we can line those up, add them up, right? What is this number now in scientific notation? How do we go back to scientific notation?
5.02 times 10 to the third power.
Yes. So is there an example of a problem from class that you added or subtracted that you remember being like, oh yeah, that was really tough for me?
No, she does a science Khan Academy,
Okay.
and then we just do it.
Is there any questions from that? I mean, I'd be happy to pull one up if needed, but I'll just make a few more up here. Okay, so 4.5 times 10 to the minus 4 plus 9.6 times 10 to the minus 3. So let's convert both of these numbers to standard form. What is this first one in standard form? How many zeros go after the decimal but before the number 4?
3.
3, because it's one less than that. It's 1, 2, 3, 4, 5. Okay, and then this one over here, 0096. Okay, and again, the best thing to do is to actually just put them right on top of each other and add this way. So this is 0. I'm sorry. This is 5. Let me erase that. Go away. Okay. Let me get that in there. So this is 5. No. Come on. That one. This is 5, 0, 1, and a 0 there. So this becomes, what is this number in? Sorry, there's a 0. What is this number in?
In standard form.
Yeah, in standard form.
0.005 to the negative second power.
Okay, so this number right here, we're moving the decimal place until we get a number between 1 and 10. So if I move it once, I still don't have it. But if I move it twice, I have 1.005 times 10 to the minus 2. Is that clear? Were you able to follow that?
Yes.
Okay. There's a little bit of a like, because we're doing this remotely and I can't see you. I know you could turn your camera, but just there's no confirmation other than our words. So I'll probably ask more questions than usual. A couple of things I forgot to mention just because I haven't done a first time lesson in a while. I am going to send you the notes by PDF when we're all done. And I'm also doing a screen recording, so you'll get a video of this to review later on if you need it. So I did detect just a kind of a there is a basic conversion thing here that I want to make sure that you're comfortable with. You for sure will get a question like 0.001010203. What is this number when you convert this to scientific notation? Can you give me the result? I need the number, and then it's 10, and then I need the exponent up here.
1.010203 to the negative second exponent.
So 2 only gets you to 1, 2 right there.
Oh yeah.
So it goes negative 3. So it's 1.010203. So
Okay.
the scientific notation, you've got I'll call it A times 10 to the B. So this number A, it's between 1 and 10. Like it can never be 10, but it could be a 1. So you start moving the decimal point until you get that numbers between there. And then B is always an integer. So that's like -3, -2, -1, 0, 1, 2, 3, and so on. Is that okay?
Yeah.
All right, so we're gonna do some subtracting now. I didn't do any subtraction problems, so we're gonna go. Let's see, 3.7 times 10 to the fourth minus 2.1 times 10 to the third. So again, I'll reiterate that I think that you should convert these to standard form first. So this would be 3, 7, and then 3 zeros because it's 1 less than that. It's basically you're counting the number of decimal places. And then we're subtracting. This is 2, 1, 0, 0. Okay, so we're going to subtract those. So let me know what you get here. 34,900. Convert this to scientific notation for me, please.
3.49 to the
10 to the what
fourth.
power? Fourth power, you said. Okay, great. I heard
My
that.
sister's
Okay.
in the waiting room.
I'm sorry?
My sister's in the waiting room.
Okay. I will certainly add her. Okay, added second person here to the class. Are we covering the same content or different content?
I'm doing scientific notation.
Rosie, is that who? Rosie, can you hear me?
Yeah, I can hear you.
Okay. My name is Matthew, and I'm working with your brother Roland. Are you trying to cover something different than he's covering? Tell me.
Yeah,
Okay. Is it this kind of thing where we want to do half and half, go back and forth between concepts?
we could do half and half.
Okay. Is it okay if I mute you for like another 15 minutes until I finish with Roland?
Yeah, that's fine.
Great. Okay, Roland, so I'm going to give you some more difficult ones here. Let's go 2.035 times 10 to the minus 2 minus 3.104 times 10 to the minus 3. So I still recommend that you convert these to standard form. Like if you want a method that always works, it's probably best to always convert things to standard form. So what would that be for this first one?
0.02035.
Great. And what about for the second one?
0.0003104.
Great. Now, it's best to do it where you take the second number and put it under the first number. I know it's probably been a while since you've had to do this. It's also good if you can get all the digits to line up, and then you just subtract them. I mean, I'm assuming that's something you're comfortable with or you've done before.
Yeah.
Okay, so go ahead and give me that, please.
.0200396.
Say that one more time.
0.0200396.
Like this, or
Yeah.
I'm sorry, maybe I didn't hear. Maybe I didn't hear all of that.
No, that was right.
Okay, so I'm just gonna check you here. Okay, so I got something different here, and that's why I'm asking if this is something you're comfortable with. So it's okay. We need to review this. I mean, this is a 4, right? This becomes a 10. You get 6 there, 4 there, right? 3 minus the 1 is the 2. We can't do the 0 minus 3, so we take 1, 10, that becomes a 7. So you should get 0.017246.
Yeah.
Okay. All right. So then convert this to a scientific notation number, please.
1.7246 to the negative second power.
Great. All right. So I'm detecting, I mean, this is just an observation. I'm detecting that just the subtraction is just the issue. Like if I ask you to do 0.0290 minus 0.345, could you do this for me, please?
Yeah.
Now this one, actually, let me change this first. Let me make this an 8.
Zero point 545.
0.545, great. Okay, so convert that number to scientific notation.
5.45 to the negative first power.
Great. Okay, so let's try another one here. Let's try the full thing. Let's go. So another example. Let's go 5.378 times 10 to the minus 5 minus 3.67 times 10 to the minus 6. Go ahead and give that a try here, and I'll work through it when you're done.
0.00005011.
Say that one more time. I didn't catch all that.
0.0000. So 4 zeros.
Okay.
5011.
Okay, so your instructor wants your final answer to be in scientific notation. This will be 5.011 times 10 to the minus 5. So you have to finish out the steps here of doing it, where it's remember it's your scientific notation. You go to standard form, and then you go back to scientific notation. So that you have to they call this like closing out the loop, but you're going here and then you're basically coming back here. So it is a little different from multiplication and division. Do you want to cover that?
Yes, please.
Okay. There is sort of a shortcut to doing addition and subtraction, but really it's always better to do it that way. With multiplication and division, you can just do it in standard form. So let's say it's 4.3 times 10 to the 5th, and then it would be multiplied by 1.2 times 10 to the 7th. So multiplication can be done in any order. So you can actually multiply these and then multiply these.
Okay.
So you have to do 4.3 times 1.2. They usually give you a calculator. I don't know how they're doing it now. Do you know if you get to use one, or do you have to do this by hand?
We got to use one on Khan Academy, but the teachers don't really want you to.
Okay. I mean, you can do this by hand, or it's just some extra steps. Now, these numbers on the right here, 10 to the 5th, 10 to the 5th times 10 to the 7th, they have the same base. Okay, which means you're going to add the exponents. Do you remember that rule from class or from a video you watched?
Yes.
So you keep the base, you keep it, but then you add the exponents. So in this case, you would get 10 to the 12th, and then you pair these up. So your final answer is 5.16 times 10 to the 12th. So let's try another one. Let's go 5.3 times 10 to the 8th multiplied by 2.4 times 10 to the minus 6. So I'll do these now. I'll do this multiplication. What do you get when you add the exponents here?
-2.
You're adding, remember?
Yeah.
You're adding 8 plus -6. That's positive 2. So this is times 10 squared. Okay. Do you see any problem with this number in front?
Yes.
What is the problem?
It's above 10. It needs
It's
to be
above 10, exactly. So what I suggest is you take this number and you convert this to scientific notation. Don't worry about this one right here. Just come over here and say, okay, how do I convert 12.72 to scientific notation? That would be 1.272 times 10 to what power? First. So now you can bring this part over here, times 10 squared, and then you're repeating. So it's 1.272 times 10 to the 3rd. Did you follow how I did that?
Yeah.
Okay, that's a pretty common test question, so we'll do another one. 8.4 times 10 to the 6th times 3 times 10 to the 18th. Okay, so this, I want you to try and do this example on your own, please. I'll give you about 60 seconds, and then I'll check back and work it out with you.
2.52 times 10 to the 25th power.
Excellent. Okay. All right. So now there's another possibility that can happen here, which is when we have to deal with some negative with potentially negative exponents. Let's go 1.5 times 10 to the minus 7. And then we'll go 6 times 10 to the 6th power. Okay. I'm sorry, I need to change this number to 8. Thank you. 8 times 10 to the 6. So when you multiply these together, what do you get? What is 1.5 times 8?
12.
12. And then 10, you're going to add the exponent. So it's minus 7 plus 6 is minus 1. So now we have a problem here. This 12 is really 1.2 times 10 to the 1st.
Yeah. 1.2 to the 0th power.
So these cancel. What happens to these exponents? They become 0. So the answer is just 1.2, which is okay. This is an okay answer. All right. All right. So very quickly, we're gonna do a division problem here. So let's go 9.3 times 10 to the 8th divided by 3.1 times 10 to the 6th. You divide this, and then we deal with the exponents over here. So 9.3 divided by 3.1 is 3. And then here on this side, you're going to subtract the exponents. So that becomes 10 squared. So let's do another.
Isn't it 3.3?
9.3, 3.1 times 3 gives you 9.3. So that's why the answer out in front is 3.
Oh, okay.
So you can always do it in reverse. So let's go 8.4 times 10 to the 4th divided by 4.2 times 10 to the minus 3. When you divide, I'm choosing nice numbers, you get 2. Here it's 4 minus a minus 3, so it becomes 10 to the 7th. I want to get one more example, and then I'm going to have to switch over to your sister. Let's go 4.5 times 10 to the minus 7 divided by 1.5 times 10 to the 8th. When you divide these numbers, you get 3. And then here you get 10 to the minus 15. So you can actually move back and forth as much as
Okay.
All right, so let me. I'm gonna mute you, and if there's any time at the end, oh, you've already muted yourself. So I'm gonna. Rosie, are you there?
Yeah.
Rosie, my name is Matthew. What would you like to work on today?
I have a study guide for my upcoming test.
Great.
So I was hoping I could go over it.
Yeah, so I always start my lessons. This is on the booking page, so you can send anything you want to work on to learning@mathbymatthew.com, and I will pull it up to whatever you want to work on. So if you could get it over to me there, that would be appreciated.
Okay. Did it send?
I will check right now and see what I got here. Yep, I got quarter one bench mark study guide. Okay, so I'm going to download this file. Is there anything that you want to start with? Is there something that's more pressing than something else?
Functions.
Functions. Okay. Functions. So I'm looking at this. Which page are you referring to? Because I don't see anything on functions here. I see.
Oh, I thought there would be one on there.
There's solving equations, which could be kind of related to it. Pythagorean theorem. Is this the right thing? Let me new share this because maybe I'm not looking at the right thing. Let's see here. So I'm sharing this is the study guide you sent me. Is this what you want? Okay, so help me out here. Is there somewhere
I'll work on the bottom page.
the bottom page? All right. So the find the distance between?
Yeah.
Okay, excellent. Okay. What I'm going to do here is go back to sharing the workspace. And I mentioned this to your brother. What I'm going to do is send you guys a PDF of this at the end. And then I also screen record. So I'll send this as a video when it's all done. There's a slight delay with a few things, but all right. So find the distance between 2 points. There are a couple of ways to do this. One is to use the distance formula. Have you seen that?
No.
Okay. Another way is to draw a triangle. Have you seen that?
Yeah.
Okay. They're basically the same, but if you have a preference, you have a preference. What is the base of this triangle? How wide is that? I'm not sure how easy that is to see. Can you see that, or is it
5 units?
5 units? So it's got a base of 5, so I'm going to make a big 5 there. And then what's the height here?
I think it's 5. Oh, no, 4.
It is 4, yeah. You'll be able to count that much easier. So then you likely learn the Pythagorean theorem, is that right?
Yeah.
Okay, so I call it PAG because it's just shorter. That's a squared plus b squared equals c squared. A and b are always the legs of the triangle. They're the short ones. So that's a, that's b, and then c is always the hypotenuse. So the advantage here is that you know the 2 legs. You know one of the legs is 5. The order doesn't matter. Squared plus the other leg squared equals the hypotenuse squared. What is 5 squared and what is 4 squared?
5 squared is 25. 4 squared is 16.
Okay. And when you add them together, you get 41 equals c squared. You have to take a square root of both sides. So c equals the square root of 41. And this is the distance. Is that okay? Is that clear?
Yeah.
Okay. I've got this great graph paper on here. So let's pretend like I'm gonna have you. We're gonna draw a triangle or a line like this, and give me the base and then the height of this triangle here. So what is the value of c? Can you give that to me?
Yeah.
So we have 5 squared plus 2 squared equals c squared. 5 squared is 25. 2 squared is 4. 29 equals c squared. Take a square root of both sides. And c equals the square root of 29. I'm going to snip in this last picture and we'll work through We'll work through the last one on the page here. Let me snip that in. Okay, so I know it's on my screen, so maybe it's not that easy to see, but we want to draw a triangle. Now it doesn't matter. You could draw this triangle up here, above it, whatever you like. You could also draw the one that goes underneath. You just need the two legs. You need the two legs. So what is this base and what is this height?
Base is 3. The height is 4.
Excellent. Okay. So we have a squared plus b squared equals c squared. In your problem, a is equal to 3 and b is equal to 4. So that's 3 squared plus 4 squared equals c squared. That's 9 plus 16 equals c squared. 25 equals c squared. What number squared is 25?
5.
5. So c is 5. All right. Okay, where would you like to go on this other review? Would you like to look at anything like 1, 2, 3 here, the missing sides? Would you like to move to something totally different? Deciding whether
Solving
they're...
equations.
Say that again?
Solving equations are square and cube roots.
Okay, so solving these equations. Excellent. Okay, yeah. I'm going to just go back to sharing our workspace, and I'll just copy in the questions as needed. So the first one, A, it says x squared equals 81. This is one of the most common questions that gets asked because it actually has two solutions. Now, if you don't know why there's two solutions, that we can talk about that, but almost everyone gets the fact that, okay, it's 9, but what's the other solution to this? Do you know?
You square 81.
Okay, so I can see there's a bit of a disconnect here. So I'm going to just review. 1 squared is 1. 2 squared is 4. 3 squared is 9. Are you comfortable kind of squaring going up with this? Yeah. Okay, great. Now, what's not often covered is that -1 squared is 1. -2 squared is 4. -3 squared is 9. So notice you get the same output, but you have different inputs. Well, how can that be? Well, when you take the square root of a number, so let me scroll up here. When you take the square root of x squared, the square root of x squared equals plus or minus the square root of 81. Have you seen that in class or anything like that?
No.
Okay, here's what's actually happening. The square root of x squared is actually the absolute value of x. And then when you take the square root of 81, you get 9. But what two numbers, when you take the absolute value, do you get 9? 9 and -9. Now, if that wasn't clear, because I didn't hear anything to indicate that was clear, what most students do is they just put a plus or minus in front of it, in front of the number. So like, let's say I asked you to solve x squared equals 16. When you take a square root of both sides, you put a plus or minus in front of the number that you're taking the square root of. Plus or minus in front of the number taking the square root of. So on the right, what does this become? What is the square root of 16?
4.
It's 4, but it's plus or minus 4. There's always two answers. Always two answers. So this type of question can come in various flavors. Like I could say 3. Actually, let's go to C. C says x squared equals 64 over 121. We're going to come back and do B, but B is slightly different. I don't know why it's in that order. When you take a square root of x squared, it's plus or minus the square root of 64 divided by 121. There is a property square roots that says this is really the same as the square root of 64 divided by the square root of 121, plus or minus. Have you seen that before?
No.
No. Okay. I have no idea how you're supposed to do this then if you haven't seen that. Without getting into the why, we're not really covering the why today. This is just the what to do. You take the square root of the top number, the square root of the bottom number. What is the square root of 64? Or what number squared gets you to 64?
8.
8. And what number squared gets you to 121?
11.
11. All right, so this is your answer over here, plus or minus 8 over 11. I would like for you to try letter D on your own here. It says x squared equals 49 over 144. Go ahead and give that a try. I'll give you 30 seconds, and then we'll go back and talk about letter B.
Is it 7 over 12?
So if you just wrote, let's say this was the box where I wanted the answers, and you wrote 7 over 12, and this was a 10-point question, I would give you 5 out of 10, which means you've either done it completely half wrong or you've only given me one of the two answers. What is the other answer in this case?
Plus minus 7, 12. 7
Okay.
over 12.
Okay, so I realized something that I did was very unclear. When someone writes plus or minus in front of a number, what this means is it's positive 3, and we don't write the positive, and it's negative 3. So you could either write 3 and negative 3, 3 or negative 3, but I want to be super clear here that what you don't write is 3 comma plus or minus 3. This means that the plus goes with it and then the minus goes with it.
Okay.
All right, so let's try a number or letter B. I'm not sure why this is in here. Cubes are very different than squares. They have different properties altogether. What this number, though, it tells you, it means take a number, multiply it by itself 3 times, because that's the exponent, and get to 64. So there's a list of these that you need to know. There's like 2 squareds, 3 squareds, 3 squared, 4 squared, 5 squared, 6 squared, 3 cubed, 3 to the 4th, 3 to the 5th, 4 squared, 4 cubed, so on. Do you know what number multiplied by itself gets you to 64? It's
8.
so 8 times 8 gets you to 64, but then another 8 gets you to a much bigger number. It gets you to 512. So that's too large. So this is where it's a bit of a guessing game. It's almost like I have to tell you the answer, which is okay. There is a list of these that's worth knowing. So in this case, 4 times 4 times 4 is 16. 4 times 4 is 16 times 4 gets you to 64. So the answer here is x equals 4, but it's only positive. It's only positive because what is negative 4 times negative 4 times negative 4? Well, let's look. These two negatives make a positive. So that's 16 times negative 4. That gives you negative 64. So if you follow that, let me give you a simpler one here. X cubed equals 27. So what number times itself 3 times, meaning, x times x times x times x gives you 27. What number times itself 3 times gives you 27?
4.
So 4 times 4 times 4, again, that's 4 times 4 is 16, times another 4 is 64. That's too big. Okay. So 2 times 2 times 2, 2 times 2 is 4, times another 2 is 8. That's too small. So what about 3 times 3 times 3? Well, 3 times 3 is 9. 9 times 3 is 27. Now, what about negative 3? What is negative 3 times negative 3 times negative 3?
Negative 27.
Negative 27. So is this a solution? Does this, are these the same?
No.
No. So only one of them works. So the odd ones are slightly different. So let's do one more here. X cubed equals 125. Okay, so give that one a try. What number times itself gets you to 125? How are you doing on this?
I don't know.
Okay.
I'm trying to figure it out. So.
Okay, that's okay. That's a good answer. Because I don't know how familiar you are with this, but I'll just make a list here. So the answer is 5. 5 cubed is 125. How do I know that? Well, it's something that when you know the exponents, like there's kind of ones that you start seeing patterns in, like because it ends in 5, you know that you had to use a 5 to get there, because 5 times 5 gives you 25, but then you got to multiply by another 5 to get 125. So it doesn't look like there's going to be a ton of these on the test, but you'll definitely want to be familiar with a few of them. We did solving equations. What should we do next? Should we do Pythagorean theorem? Find the missing side? Should we go up and look at any sort of rational versus irrational numbers?
Law of exponents.
Law of exponents. Okay, great. I'm going to snip in the is there ones in particular you want to do, or just the mixed rules?
The ones with like unknowns, so like X or Y, like on number 5B,
Mm-hmm.
or the ones on number 6.
Okay. So the zero exponent, your instructor is trying to be deceptive by putting that one in. The rule is anything to the 0 power is always 1. So I like words. Anything to the 0 power is always 1. So what your instructor is trying to do is saying, okay, well, let's put a bunch of stuff that the students have never seen before, but let's put it to the 0 power. The instructor wants you to focus here, but where you need to focus is there. That's the one you need to be focusing on, because anything to the 0 power is It's always 1. So it doesn't matter what goes here. Like let's say on your exam you get 4xy squared over 3zp to the 5th all to the 0 power. What does this equal?
1.
1. There are some things with variables, but they're not in this problem. So we're gonna say that we've covered that. Now the mixed rules, there's kind of the problem here is the way you like to learn is you like to take these little steps and increase your understanding sort of gradually. With these mixed rules, it's like going like this, meaning they're not giving you as many intermediate problems to work on. But I'll try to do my best to help you out here with these. You'll notice I'm writing it slightly differently than the way that it's presented on the page. I'm putting more white space because there's actually 3 separate problems here. There's this one that I just circled, then there's this one, then there's this one. So when you are dividing, as you're doing here, and the bases are the same, what do you do with the exponent? What do you do? What is the math operation between these exponents? And if you're not sure, it's just up in number 2. It's the quotient rule. You remember that?
You divide them.
You're dividing the numbers, but if the bases are the same as they're here, you subtract
them.
Yeah, and in the beginning, it's really a good idea to actually write it out. So here the bases are the same too. Okay, the bases are the same. 3 minus a minus 6. 3 minus a minus 6. If you don't write it out, sometimes you put the wrong number here. What is 3 minus a minus 6?
-9. No.
Positive 9, because you're these two cancel out. It becomes 3 plus 6.
Oh yeah. Okay.
Okay, so let's look at the next one here. 3, and then we've got we're going to subtract the exponents. So -2 minus 5. So notice I put that second number in parentheses. -2 take away 5. It's like my bank account is -$2, but then I try to buy something, my bank account goes even more negative. What does that become? -7. Okay, so this is a common thing that I've seen in the past where people struggle with. So we're gonna talk about that, -7. Now here, this next one is very similar. So it's -3 minus 6. -3 take away 6. They're both negative, so the answer has to be negative. That's another way to do this. And since they both have the same sign, you add the numbers to get 9, but you keep the negative signs. This is 4 to the -9. All right. I'm gonna do I'll do the last question here, but I think that there's some understanding. We could definitely spend some more time on this in the future on these negative exponents. They're very difficult, kind of classic exam questions that just everyone struggles with. So again, this is really 3 separate problems. The first one, the exponent is 8. And because you're dividing and the bases are the same, you're subtracting the other exponent. You're subtracting -3. When you subtract a negative, it has the effect of making it positive. For the next one here, 5 to the -6, it's -6 minus the bottom number, which is 6. I always put that second number in parentheses. So it's -6 take away 6. Because they're both negative, you keep the sign, and then you add the numbers as if they don't have a sign. Last one here, 2 minus a -4. Again, notice how I always put that second number in parentheses. 2 negatives become a positive. This becomes 6, so it's times 7 to the 6. So unfortunately, we are out of time for this lesson today. Let me just remind you that you can I've got a virtual homework help tomorrow night, and that would be a great opportunity to kind of continue this discussion. It's a free class every Monday at 7 p.m. And if you just go to Meet with Matthew, free homework help class, I'll be happy to continue answering some of your questions there. But I do have to end the lesson, and I'm going to send these notes to you by PDF right away, and then the video of it will come within 24 hours. There's a Zoom delay and then an upload delay. So I really appreciate your time, and look forward to helping you again.
Thank you.
You're welcome. Bye now.
Bye.